Lesson 3.1, Task 3. Graph transformations of parent polynomial functions. Previously, you examined transformations of the graphs of functions. Writing equations of transformed functions was limited to absolute value and quadratic functions. Now you will use similar techniques to examine and write transformations of polynomial functions. As with absolute value and quadratic functions, it is helpful to understand the effect of the transformation on the three reference points found on the graph of the parent function. The table lists these 3 points for the parent function f of x and the corresponding points on the graph g of x. Alright, so you've seen it before a function that looks similar to this. G of x equals a times 1 over b in parentheses x minus h to the n power plus k. Before it was either absolute value or it was a squared term, but now because we're working with polynomials, it's the same general formula except the power could change. It could be x squared, x cubed, x to the fourth, etc. So if we have f of x equals x to the n, this would be considered the parent function, and then this would be your transformation. So you can see how it's got the reference points, and then the new points would be moved to whatever the transformation does using the a, b, h, and k. So it says identify the transformations of the graph f of x equals x cubed that produce the graph of g of x. Then graph g on the same coordinate grid as the graph of f. Alright, so you can see that they've added the 1/3, x plus 1 cubed minus 2. So there's no b, but there's an a, and there's an h and a k. Alright, so a is 1/3, b is 1. So if there's no b, it's just assumed to be a 1, just a placeholder. And then h would be -1, because remember it's opposite h, so the plus 1 would actually be a -1, and then k is -2. So those numbers come straight from the equation given. So in general, what do the parameter values a, b, h, and k tell you about how the parent function is transformed? Alright, so a is a vertical stretch or compression. B is the horizontal stretch or compression. H is your horizontal movement. And K is your vertical movement. Alright, so it says describe how the graph of G is related to the graph of F. Alright, so it says a vertical compression by a factor of 1/3 and a translation of 1 unit left and 2 units down. So this is just a verbal description of what this right here says. Okay, given your A, H, and K, they just put that in words to describe it. Alright, so it says what values would result in a vertical stretch of a parent function? Alright, so we've seen the vertical compression is 1/3. So if we want to stretch it, we have to have a value greater than 1. Alright, it says create a transformation table and graph the functions. Alright, I'm going to blow this up a little bit, make it easier to see. So we have f of x equals x cubed, and then g of x, this is the x cubed transformation with the 1/3, the -1, and the -2 put into place. So we can use those reference points, and we can find the new reference points that go along with g of x. Alright, so you can see the blue function is graph. That's your original x cubed parent function. And then in red, this is the transformation. So the 3 reference points have moved to here, and then the curve has been sketched. So these are just the turning points. You can use any points you want, but these are good reference points to use for sketching a graph of a transformation. Alright, it says why are these 3 reference points used to graph a transformation? And again, I would say that's just like the turning points. So it says the points give you the turning point, and the 1 point on either side. Yes, other points could be used as long as the turning points are included. All right, so that's all for task 3. If you have any questions, let me know. Lesson 3.1, task 4. Graph transformations of parent polynomial functions. Identify the transformations of the graph of f of x equals x to the 4th that produce the graph of g of x. Then graph g on the same coordinate grid as the graph of f. Identify the values of the parameters a, b, h, and k. So if you look up here, a is 1, b is 1 over b, so b is 2, h is 3, and k is 1. Describe how the graph of g is related to the graph of f. So in words, this would be a horizontal stretch by a factor of 2 and translated 3 units right and 1 unit up. All right, could you rewrite the equation of g of x so that there was a vertical compression but no horizontal stretch? All right, so what they're asking is, could you take this 1/2 and make it be outside the parentheses instead of inside the parentheses? If it's outside the parentheses, it would reflect the a instead of the b. So we could do that. We could take 1/2 and raise it to the 4th power, and then that would be outside. So 1 to the 4th is 1, and 2 to the 4th, 2, 4, 8, 16. So it'd be 1 over 16 would be your stretch. Let's see what the answer says. It says, yes, you could evaluate 1/2 to the 4th power in order to pull it outside the parentheses. Okay, so basically the exact same thing that I said. The value of a would be 1/16, and the value of b, and after that was performed, then b would be 1. All right, create a transformation table and graph the functions. All right, so you got f of x equals x to the 4th. That's your parent function. Here are your reference points, and then it's going to take g of x and apply the transformations to it. So g of x will be 1, 2, 3, 1, and 5, 2. What does the second row indicate about how a stretch or compression affects a point at the origin? Okay, so the point at the origin, it's moved based on the horizontal and vertical transformations, but it's not affected by the stretch or compression. So that's why the A or B does not affect that. All right, when you look at the graph, here's your parent function, x to the 4th power, and then here is the transformation. All right. Does the graph of g appear to match the description based on the analysis of the parameters' values? So let's look back and see. It's going to move it a stretch by a factor of 2. It's going to move it right 3 and up 1. So it's going to move it right 3, up 1, and then stretch it. So yes, that does look like it matches what it's supposed to. All right, that is all for task 4. If you have any questions, please let me know. Lesson 3.1, task 5. Write equations for transformations of parent polynomial functions. Given the graph of the transformed function g of x, you can write the equation for g of x by determining the values of the parameters using the same reference points examined in task 3 and 4. The general equation for the function shown in the graph is g of x equals a times x minus h to the 4th plus k. Write a specific equation for the function. So we're given these 3 reference points, and so we're just going to work backwards in order to find out what our a, b, h, and k are. All right, so it says create a table using the given points for the graph. All right, so we know our original reference points for x to the 4th are these 3 points. And we know that we can use -1 times b plus h equals, in this case, we're going to use 0 and -3 and 3/4 as our y. So all we're doing is using these reference points that we're given, and we're kind of working backwards to get our h, our a, and our k. So in this case, there is no b value. So if I have -1 plus h equals 0, I can add 1 to both sides, and I know that h is 1. And here I can do the same thing to find my A and K. So I can look at 0. I can look at the middle one first because this would just be 0. So that means K has to be -4. And then I could take -4 in and plug it into one of the others to find the value of A. So that's exactly what they did here. To solve for A, substitute -4 in for K in number 1. And then A plus K equals -3 3/4. So if you simplify that, that means A is 1/4, positive 1/4. All right, so once I have H is 1, K is -4, and A is 1/4, I take those three values and I just plug it into the function J, and that gives me my new function. So here's J of X, and then they plugged in A is 1/4, and then H is 1, and it's always opposite H, so that's -1, and then my K value is -4. All right, so how's the process for writing the equation of a transformed function similar to graphing the transformed function? Well, you're using the reference points just like you do to graph it, so that's what it would be. Let's see what it says. The points are used to identify the parameters instead of the parameters being used to identify the points. So it's kind of just making sure you're using those three reference points to know what to do. All right, that's all for task 5. If you have any questions, let me know. Lesson 3.1, task 6. Write equations for transformations of parent polynomial functions. The general equation for the function shown in the graph is J of X equals, and this time we've got the B, so we've got parentheses 1 over B times X minus H raised to the 3rd power plus K. Write a specific equation for this function. All right, so they're giving us the general equation here. So we're looking for a B, an H, and a K, and they give us these 3 points, the 3 points, turning points here. So X cubed, these are our 3 reference points. We plug these in. You can see -7, 0 is your first turn. -4, 1 would be like the vertex or the turning point there. And then -1, 2 comes from this top reference point here. All right, so given this table, we can work backwards to find B, H, and K. So if we use the middle points here, we know that 0 times B is 0, so H equals -4 and K equals 1. So that's the easiest two to find. H -4 and K equals 1. Once we find that, we can use these values in order to find the B value. So if I know H is -4, I can put -4 in here and add 4 to the other side, and I know that B equals 3, or 1B equals 3, which is the same as B equals 3. So that gives me my H, my K, and my B. So it says write the equation for the transform function. We take our general function, J of H here that was given above, and we put in 1 over B, B was 3, and then X minus H, X minus a -4 makes that a +4, and then +1. So this would be our transformed function. All right, how can you use the given general equation to write the specific equation for the function? Well, just like we did before, take the points that you are given on the picture and just plug it into the reference points and see where they have been moved to, and that allows you to find your B, your H, and your K. All right, that's all for task 6. If you have any questions, please let me know.